What materials can you apply to achieve passive fire resistance rated construction for building elements, components, or assemblies? We would consult Chapter 6 to figure out what the rating requirements are for various elements of our building. Then we would review Chapter 7 to find the right material assembly to achieve the ratings for various building elements. The materials of construction are specified as of 2024 in the following tables. Table 721.1, Table 721.2, and Table 721.3. For materials that change the fire resistance of that assembly, fire test results or other substantiating data are made available to the building official to show that the required fire resistance rating period is not reduced. Let's say that we have a steel column and we need that component to achieve a 4-hour fire resistance. And let's say that our goal was to stick to finding a prescribed code solution rather than come up with our own assembly test. Well, we start by looking at Table 721.1, which describes the minimum protection of structural parts based on time periods for various insulating materials. The first column describes various types of structural parts to be protected, while the next column is the insulating material to be used, and then the hour ratings for that assembly, and then the provided minimum thickness required to achieve that rating. Scrolling through this table, we find the first item labeled steel columns and all primary trusses. We're looking for an insulating material that provides a 4-hour rating. According to this table, there's only one assembly that achieves this, as shown right here. It's an assembly that has a 4-inch hollow clay tile in two 2-inch layers with 1/2-inch mortar between tile and column, with a 3/8-inch metal mesh and a 0.04-inch wire diameter in horizontal joints, and a tile fill. Well, that was a mouthful, but that assembly essentially achieves a 4-hour rating. What if you're looking to use rebar in reinforced concrete columns? Then the same table prescribes here 2 options. One that has carbonate and another that has siliceous aggregate concrete, and provides the thickness of the assembly to achieve anywhere from a 1 to 4-hour rating. What if you have a brick or CMU wall part of your building design? Table 721.2 provides 4 different options for brick and 4 different options for concrete masonry units, or CMU. One of the most common assemblies found in this table is labeled as number 12, as wood studs interior partition with plaster on each side. Notice how the thickness and the type of gypsum used in the wall assembly can lead to either a higher or lower fire rating. This table also has a label for exterior or interior walls, so make sure you choose the correct item before you look at what the assembly should be made of. The assemblies listed are by no means an exhaustive list in any of these tables. The designer will often refer to other testing agencies that are acceptable to the code, such as Underwriters Laboratory or Factory Mutual, to find assemblies that meet the needs of the project. The designer must use these assemblies with care and identify only those that are used in a project. Modifications to these assembly designs should be done with caution, as they may negate their approval and necessitate fire testing to prove their efficacy. When project conditions cannot be met using these prescriptive assemblies in this section, then the Chapter 7 section on calculated fire resistance provides a method to calculate the fire resistance performance of specific materials or combinations of materials. These calculations are developed for use in the code and meant to apply only to the section in which they are contained. They are designed to facilitate how to design and document fire assemblies so the designer and the AHJ can have some level of assurance of the performance of the calculated assembly under actual fire conditions. The formulas are based on data for heat transfer in structural members, thermal conductance of insulating materials, conduction in materials, fire test data of the fire resistance of various building materials, and both individual versus together, the anticipated loads on these assemblies. We can use the data in this section to determine fire resistance for assemblies that do not fit neatly into the prescriptive pre-tested categories mentioned earlier in the chapter. In the calculated fire resistance section, it is divided into the following sections: concrete assemblies, concrete masonry, clay brick, tile masonry, steel assemblies, wood assemblies, and fire resistance rating for mass timber. If your building project is similar to, say, the architect Toyo Ito, and you're using, say, precast concrete slabs for your wall assembly, then Chapter 7, Table 722.2.1.1, and that is the code reference as of 2024, has a table that describes precast concrete walls, load-bearing or non-load-bearing, and describes the thickness of a 4-hour rated wall. Silicious concrete would have to be 7 inches thick, while lightweight concrete could be 5.1 inches thick. As an example, if you have steel columns in your building and you're looking to protect them with intumescent paint, which is a great way to keep columns exposed in your building if that's part of your design goal, then this section states that the fire resistance of structural steel columns protected with intumescent or mastic fire-resistant coating shall be determined on the basis of fire resistance tests in accordance with 703.2. Then, if we click on 703.2 and it directs us to 703.2.1, it says that these assemblies are to be determined according to test procedures set forth in ASTM E119 or UL 263. If you're wondering, what are all of these organizations about anyway? Well, the American Society of Testing and Materials, or ASTM, plays a critical role in the construction industry because they develop all the standards that support design, construction, and performance of buildings. ASTM standards specify performance requirements for materials used in the construction industry, such as insulation systems, structural members, and construction sealants, to name a few. Remember this, though: ASTM does not conduct the actual testing of materials. They only create standards and provide training and education on these standards. What about the other organization, UL, that's mentioned in the code? UL stands for Underwriters Laboratory. And unlike ASTM, UL is an organization that actually tests and certifies all kinds of products used in the construction industry to ensure that they meet safety standards and makes this information available to the public. Factory Mutual, or FM, is yet another organization that sets rigorous standards for building materials and systems, and also tests them to ensure that they meet high levels of fire resistance and performance, again, against all kinds of hazards, not just fire. They provide certification that products can withstand extreme hazards, such as wind uplift in a hurricane, which is often required by insurance companies if you live in certain regions. They provide certification that products can withstand extreme hazards. Let's review what we've learned so far. Question number 1. Look up ASTM E119, as was described in the video earlier, and describe briefly what types of information is contained in this standard. Number 2, using any of the organizations mentioned, look up any building component for your own project and find an assembly that provides a 4-hour rating, or any other hour rating that you're trying to achieve. List the organization, the assembly name, the materials in that assembly, and the hour rating that's provided. And number 3, to save cost and time, which fire resistance method from Chapter 7 would be recommended and why?